In this video we are going to look at some basic properties of logarithm, right? So let's say I have a logarithm of base a. So for any base a, so the number one property is a logarithm of a base a is equal to 1. Number two property is logarithm of 1. Logarithm of 1 of any base a equal to 0. Number three property is logarithm of a power x base a equal to x. And number four, the property is a power logarithm of x base a is going to be equal to x. All right, so that is basically the four basic properties of a logarithm function with any base a. Now let us look at another type of function, which is common logarithm, right? So let's see the definition of common logarithm, right? Common logarithm. If a logarithmic function have a base 10, so if my logarithmic function base equal to 10, then this logarithm is going to be called common logarithm. The reason is in our professional life or normal life, we encounter a lots of logarithm which are with base 10. So let's see. So logarithm x base 10 is actually expressed as simply logarithm x. So if you find that that the base is not mentioned, then you need to assume that base is automatically 10. All right, so that is so now let's look at the four properties. So I can say logarithm of 10, remember, as I did not write base 10, it is 10 equal to 1, and number 2 is logarithm of 1 equal to 0. Number 3 is logarithm of 10 power x equal x, and number 4 is 10 power logarithm of x is equal to x. So this is the properties of common logarithm. Now let's look at the last one, which is natural logarithm, because it occurs a lot in the nature. Okay, so natural logarithm. So if a logarithm have a base e, remember e is the Euler number we learned in previous videos, so then this type of logarithm is going to be called natural logarithm. All right, so if I have a logarithm x and base e, so this logarithm is written in most of the book as ln. Okay, ln x. So ln means natural logarithm. All right, so whenever you see ln x, you need to understand that this is a logarithm base e, right? So let's look at the properties of this function. It will be basically ln e is going to be 1, So number 2 will be natural logarithm of 1 will be equal to 0. Number 3, logarithm e power x is going to be equal to x, and number 4, e power natural logarithm x is going to be equal to x. So these are my 4 properties of natural logarithm. All right, so now what I am going to do, I am going to solve a problem which is involving interest and continuous compound interest. So let us look at the problem description. Okay, so the problem is so let's look at the problem. So this is the description of my problem. So what is the problem says? Problem says that how long it is going to take to double your money if it earns 6.5 interest, and that interest is compounded continuously. Okay, so so in this case, let's say double your money. So we do not know how much money you put. Let's say we put our principal money, so principal amount, let's say you put in the bank, let's say $P. Okay, so if you want to receive a double amount of money after t years, so time is what? Time is t year, which we do not know. Okay, we need to find that t year. Now, so your amount, so after t year your money amount will be double. So that means your A is going to be what? Double of P. All right, remember what is A is the amount of money you receive, amount of total money you receive after t years, so it will be 2p. Okay, so that is our problem statement. And what is the interest rate given? Interest rate given R is what? 6.5% interest rate. So 6.5%, and remember I need to express R in decimal point, so it will be 0.065. Now you need to look at another thing. Interest rate is compounded continuously. So for continuous compound interest, so for continuous, so let me write down this theory. For continuous compound interest, the equation is A equals P e power RT. We have seen this formula before. So now let's manipulate a little bit. So if I write A over P equals e power RT, now this is an exponential expression. So now if I express this exponential expression into equivalent logarithmic expression, I can write down natural logarithm of A over P equal to RT. Okay, that is I can write as a formula. Okay, so now let's apply this formula here. So what I have here is so let me write it here, that logarithm of A over P equal RT. Okay, let's put the value here. So ln, now what is my A is 2p. What is my P is P equal RT. Okay, oh, so what is my R? 0.065, and T I do not know, I need to find, so T is T. So what I get is natural logarithm 2 equal to 0.065 T. All right, so what is going to be my T? So my T is going to be natural logarithm 2 over 10.065, and if you punch the calculator, you are going to find that it turns out to be t equal to approximately 10.56 year. Okay, so what does that mean? That means that in almost 11 year, 10.566 or so I think 10.66. okay, so guys, sorry, I made a mistake. So in 10.66 year, or almost in 11 year, you are going to see that your money is going to be double. All right, with an interest rate of 6.5% interest rate. Okay, so that is going to be the end of this section. So see you in next